Hi guys, BuildZoid here, and today we're going to be taking a look at another custom PCB RX, oh no, the brush is too small, RX 5700 XT, this time the Powercolor Red Devil PCB, and of course the pictures are from Tech Power Up, so huge thanks to them for, doing reviews where they include really high-res PCB shots, because it makes my life so much easier when it comes to making videos like this. There will be a link to their description their review down in the description below. I am very good with words today, aren't I? So let's get right into it. Starting off with, of course, the most important VRM and the biggest VRM, the V-Core, located right over here. And I'm inclined to believe this is an engineering sample board because there's like almost no missing components. Or Powercolor decided that they're just going to spend all of the money on this thing, which is also possible because this is their, top of the line card for the 5700 XT. That's not very legible, but I don't really care. So that's our V-Core. Then, of course, in standard RX 5700 XT fashion, we have the split memory VRM, which is a... there's only one card that doesn't do this, and that's the Strix. And honestly, for LN2 overclockers, this is just no. This is absolutely... Those two capacitors are just completely unacceptable, but I don't think there's that many people interested in taking a 5700 XT Sub-Zero. I'm mildly interested in it, but I'm not interested in paying for a 5700 XT, especially considering, the only one where it... because if I bought something like this, these chokes are also a hazard, so it's you need to figure out something for those, and it's just okay, well, at that point it's a pain, and then it's okay, so the only card that doesn't really run into that is the Strix, and that one's really expensive. I don't feel like paying 2070 super money for a 5700 XT. So yeah, even though I'm a huge fan of the Strix PCB, I do agree with all of the comments. That card is extremely expensive, but it's a great freaking PCB, right? It's kind of like a Lamborghini of 5700 XTs. Very expensive, very nice, totally not worth it. Anyway, so that's our VMem over here. But back to this card. This is also a really nice card. It's less ridiculously expensive, though. And there's a good reason for that. For one thing, these capacitors are way cheaper than SMD aluminum polymers, so, it's that there are some cost-saving measures on here. So we have VMem. Then over here, we have what I suspect to be VDDCI, and I suspect that to be VDDCI because the SoC rail should be on the IR35271, which is located on this side of the PCB, and so that has to be this down here has to be the VSoC, or at least that's my theory. That's VSoC, and this over here is VDDCI. And the thing is with 5700 XTs, from what I've been reading, it seems like these have a really hard time overclocking the memory, and they don't really seem to scale with core clock because it's a 256-bit GDDR6 memory bus, and it bottlenecks the card. So the thing that, because the thing is GDDR6 actually just scales with straight memory voltage, but the thing is, 5700 XTs use the same memory that NVIDIA cards use, and you regularly see NVIDIA cards hit 16 gigabits per second on stock memory voltage. So my theory is basically there's only two things that could there's only a couple things that could be wrong. The memory power delivery sucks, as in it has too much noise on it, and the memory doesn't overclock because of that. The PCB sucks, so the signal integrity is so low that you just can't push high frequencies without a bunch of errors, or the memory controller sucks, which I think is the likeliest option, in which case messing around with VDDCI and VSoC might fix the the memory overclocking, but this one is inaccessible through software, as far as I know. I don't think that one's accessible through software, which is interestingly enough, the controller for it should be accessible through software, but yeah, I don't know. I've not been paying that much attention to 5700 XT overclocking. Also, this rail has a nasty if this is VDDCI, this has a nasty habit of blowing up the memory controller. If you if you raise this just a little bit too much, say 200 millivolts, you can very easily end up with no memory controller in a couple minutes. So yeah, this is a pretty dangerous voltage to play with. It's a shame that we don't see Like, I think it'd be really cool if some like AI board partner went and just like fixed the memory overclocking. If it's possible, like looked into that and fixed it. Because in my opinion, that would really like, because obviously, you know, you can design a better heatsink, you can design a better PCB, but the card does like, it doesn't really change the performance of the card that much because the memory doesn't go anywhere. So yeah, I think it would be, and also had memory voltage control, because if the memory controller started to move, then running GDDR6 on like 1.4, to say even 1.45 volts, stock is 1.35. That can give you a good couple hundred, well, okay, not couple hundred, but well, it depends on what version of like what if you're looking at effective speed or physical clock or what AMD does, which is memory controller clock, which for some reason is half GDDR6 clock. But anyway, like basically more voltage makes GDDR6 go faster. So I think it would be really cool if there was a card with like actual control over these two rails. It would probably also just not be like AMD would be total. Well, I don't know. AMD might be okay with that. It's kind of unfortunate that we don't see a card where it's like software support. On the Strix, you do get the voltage mod points, right? But that's not software support. That's like you solder to the card and void your warranty, and that's the only way you're getting that. And in that case, you might as well just solder directly to the controller, in my opinion, right? So, anyway, so that out of the way, let's take a closer look. Oh, I forgot to mention there is dual BIOS on this card. So, like the main use of dual BIOS, in my opinion, would be well, maybe like messing around with using BIOSes from different 5700 XTs. That's like the only use I could see for it. Like maybe some BIOSes are better. Like I don't know, the Powercolor BIOS on like on a different card might work really well. But because the thing is, you can't actually mod the BIOS properly, so it's like flashing a customized BIOS is not really an option because the card probably like if it's like Vega, the card won't boot, and yeah, then you're screwed. So. Anyway, well, you're not screwed. Like, you have a BIOS switch, but, you know, and you can recover it quite easily, but, like, you can't do anything with it. So, anyway, let's take a look at the VCore VRM. So, the VCore here is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 phase. And not only does it look like that, it actually is that because we have a whole lot of doublers on the back of the card right here. And this is the thing, like, this to me, like that, like all of these capacitors right here on VCore, on a lot of other cards, there are mounting points for them, but they're not populated, which is why I'm wondering if this card is like an engineering sample, because that's one of the things, like sometimes the engineering sample boards will just have more components, like they'll be fully populated, and then by the time you get the retail cards, they'll scale it back a bit because they'll be like, well, this doesn't actually lead to better anything. Like, yes, you can measure that it's slightly better, but the end, like, stability doesn't improve, overclocking doesn't improve, you know, it's basically extra cost for no gain. So yeah, but I don't know, like maybe the retail cards do have all of these, but so far, this is the first card I've seen where it's like, yeah, these are all fully populated. Though at the same time, that isn't. So maybe they are actually doing that. Maybe Powercolor's serious about that. In which case, I'm a fan of that. We all know I love unnecessary capacitors, right? If I have a card with where I feel like there's not enough unnecessary capacitors, I just add them myself. So yeah, anyway, so we do have the 5 doublers on the back. So, you know, the 35217 right here. Runs in 5-phase mode, and then that gets ×2 because of all the doublers, and it also runs a +1 for the SOC rail, or what I assume is the SOC rail down here, right? So that's what's going on with that. Let's go back to the front. And the other big difference, so basically Powercolor with this card, they have more phases than everyone, actually, because the Asus card has 5 phases, and it's like 2 power stages per phase. The reference cards are I want to say they're 6 phase. And then all of the like the MSI card, the Sapphire card, the XFX card, all of those are 7 phase. So for the VCore. So yeah. Anyway, where was I going with that? So yeah, this is a 10 phase. So this technically has the most phases. But it also like has the fully populated input filtering. So I like this should probably just put very little, like in terms of like input switching noise, it should make very little as a end result, because Powercolor is just kind of gone. Like they've got both a ton of phases and then also those fully populated capacitors on the input side, and then on the output side the same thing. So yeah, now the downside to running doublers is, of course, that you delay your PWM signals, so your transient response is, well, basically it makes it harder for the VRM to respond to changes in load, in loading. But depending on how you design the VRM, you might have other things making your transient response better that completely counteract the negatives of having doublers, right? So you can kind of do, depending on what you prioritize in your design, you can kind of do both. Or, well, you can achieve multiple things at the same time. So anyway, so yeah, Powercolor has the most phases. But they are using, I think, the weakest power stages, which, I mean, you know, that's like if you have the most phases, then you can use cheaper power stages. Well, because, well, actually, so the Strix card is just ridiculous overkill. Like this card and the Strix are very different leagues in terms of the VRM design. Very different approaches, too. But with this card, what you're looking at for the power stages is NCP 30, 21, 55s, and I screwed that 21 up. So 30, 21, 55s, and these are 55 amp power stages from On Semiconductor, and yeah, the thing is so like the Sapphire, the MSI card, and all of those use 60 amp power stages. The Asus also uses 60 amp power stages, but they're smart power stages, so they're like even more efficient than your usual 60s. I don't know why they don't just rate them for a higher current, but they just don't. So yeah, it's kind of funny. If you look at the datasheet for the TDA2, well, you can't because it's not public, but the efficiency curves for a TDA21472, which is a 70 amp smart power stage, and a TDA21462, which is a 60 amp power stage, smart power stage, basically the same. Interestingly enough, like very similar efficiency curves. So yeah, it's like it's a 60 amp smart power stage, but it absolutely blows away other 60 amp power stages in terms of efficiency. So yeah. Anyway, so this is a 55 amp power stage. So this is like it's still one of the, I think it's the second most powerful. Like it's more powerful than everything else, but it's not more powerful than the Strix. So yeah, no surprises there. But it does make this VRM still ridiculously efficient. So let's talk about that. So at 1.2 volts output, 500 kilohertz switching frequency. This is just because that's what the datasheet was spec'd in. Well, they also had 800 kilohertz and 1 megahertz. But the thing is, in order to get even 500 kilohertz here, they would need to be running a megahertz into the actual doublers. So there's a good chance the power stages are running at a lower frequency than that, which would potentially improve the efficiency a bit more. So yeah, 1.2 volts, 500 kilohertz, 5 volts drive, which I think is this down here. The 5 volts drive thing, like all of the 5700 XTs use power stages. So there's I think this is the 5 volt drive rail, but I'm not 100% certain about that. There's also a bunch of like other minor regulators where it's like I have no idea which one's which. I mean, which one does what, because yeah, can't get the information for that right now. And I don't have a card in hand to measure them so that I could at least call them by the voltage, but I don't even have a card to be able to check that. So anyway, 5 volts drive, 1.2, 500 kilohertz. So 150 amps output. This VRM will produce about 14.5 watts of, that's not 14.5. What the hell is that? 14.5 watts of heat. Which is very efficient. It's not the most efficient. The Strix can do it slightly better, because obviously that's on freaking 60 amp smart power stages, which are insanely expensive. Like, just most expensive. Like, you can't really buy a more expensive power stage. Even with the even with the ridiculous discounts that, like, the actual manufacturers get, because they buy huge volumes, those are really expensive. So anyway, 150 amps, 14.5 watts of heat. So good efficiency, and this should actually be, well, VRM might be able to deal with that without even a heatsink and just like airflow. So, because the thing is, this obviously isn't going to fit a full cover Navi water block, but personally, I'm not a fan of full cover blocks. Just buy a universal block, costs half as much money, gives you just as much cooling, and then throw a fan at the PCB and maybe thermal tape some heat sinks to the memory chips. Well, that's one advantage. Like cards with nice memory base, like heatsink base plates, like say the Pulse from Sapphire. If you throw a universal water block on that, then you have proper heat sinking for all the memory and the VRM, which is nice. But yeah. Anyway, so 150 amps output, VRM's up there in terms of efficiency. Unfortunately, funnily enough, I don't have efficiency figures for all the other cards, or at least I don't remember them. So yeah, because I haven't done those yet. It's kind of funny. I'm working from the nicest cards backwards. So like Strix, Red Devil. Then I'll probably be doing. I'll be doing the Pulse probably after this, and then I'll probably do the reference card last. So yeah, definitely working backwards. Anyway, 200 amps. You're going to be looking at about 19 watts of heat output. So still really great efficiency right there as well. And then when we go up to 250 amps, this VRM will be producing about 26 watts of heat. So at this point, you definitely need to start. 19 watts might be just about doable without a heatsink, depending on the airflow situation. But 26 watts, no. That's not happening without a VRM heatsink. So at that point, very much you need a VRM heatsink and probably some airflow through it. 300 amps output, this VRM would produce about 34 watts of heat. The requirements for the heatsink become steadily more higher. Then 350 amps, this VRM would kick out about 44 watts of heat. Which at this point, that's actually still relatively easy to deal with if you have a good surface area heatsink and then you just smash enough airflow in through it. And I do say smash because once you get the high RPM, 3,000 RPM fans even 2,000 RPM, if you jam it right up against the card, that should be able to deal with that, with a proper VRM heatsink as well. So yeah. Anyway, going up to 400 amps, you're going to see about 56 watts of heat. So here you might want to get a Delta fan. But the thing is, so honestly, if it weren't for the two capacitors right here, this I'd be totally down with running this card on, this would be a perfect card to run on liquid nitrogen. Actually, just this memory VRM layout in general just is very anti-extreme overclocking, because how you're going to mount an LN2 pot with those chokes and those capacitors right there, yeah, that's going to be that's not going to be the thing is you can't even really you'd basically have to buy a low profile. Well, no, you're not going to get a low profile 33 nanohenry inductor in this current spec, in the current rating that you need for memory power here. So yeah, this is just you can't run this. So that sucks, but still, the VCore VRM is very powerful. And if you were just running a universal water block or something, then yeah, I'd be totally, the biggest concern on the card would actually be cooling the GDDR6, not cooling the VCore VRM, or depending on the airflow situation, right? So yeah. I'm a big fan of what Powercolor's done with the VRM here. And it's kind of interesting. Powercolor sometimes has really terrible custom cards and sometimes really I don't think they've ever had the straight up best card, but they've definitely had some of the better ones. So yeah, this one's definitely one of the better ones. Currently, it's actually kind of the second best 5700 XT you can get because, Sapphire, MSI, XFX, they're all using the same PCB with the exact same parts. So actually, I think they might change I can't remember right now. I think they're all using the exact same parts. They might actually just be buying the PCBs from the same factory at that point and just smashing, using different coolers. It's not a reference PC. Well, it's not a reference PCB though. It's customized. It looks like this minus a couple phases and different power stages. So anyway, but Powercolor's VCore VRM, I'm a big fan of it. Also, worth noting with the capacitors, these are APAC, which is basically what everybody else is also using. I really have a sneaking suspicion that the 5700 XTs are all being built by the same factory, and then people just Emma, the PCBs are identical, so I'm very, very suspicious that these are like, well, I guess it could also be some like reference design that everybody's using. But the thing is like even the capacitors are the same for everyone. So yeah, APAC, and these are 5,000 hours rated. But yeah, the thing is these are through-hole aluminum polymers, so like the thing is the reference design uses SMD capacitors, but the reference design also doesn't have a bunch of multi-layer ceramics on the output of the VRM, so it's just like that's kind of how like that's the big difference here is like because these are so like these are worse in terms of ESR and ESL compared to the SMD polymers, which you would see on the reference card. Basically, all of the cards that use this style of PCB, let's just call it this style because it looks really similar. Like Powercolor just has more phases than everybody else here. With this style of PCB, what you do see is a bunch of extra multi-layer ceramics, basically to make up for the fact that these have terrible ESR and ESL. Whereas the reference card just has a bunch of aluminum polymer, like SMD polymers, and no ceramics whatsoever. Well, almost no ceramic. Well, no, it's not almost no ceramics. There are still ceramics. There's just a lot less of them, and they're located like in between the inductors. And there's a couple of them. It's not, like I think Powercolor's really gone overboard with this card, like because they've filled out all the ones on this side. And they obviously filled out all the ones on the backside, and yeah, so it's kind of the main differences here with like this. Well, actually, all of the cards against the reference card, because even Asus technically isn't using. Well, they have them for memory, but they don't have them for VCore. Because the thing about the SMD polymers, very expensive, very very expensive compared to the through-hole ones. So anyway, the memory VRM and the VDDCI are handled by this chip right over here, which very conveniently says right on top of it what it is. That is an NC, but just in case you can't see that, that is an NCP 81022. This is a chip that was very common with, I think it was originally introduced with the R7 260X. This is, oh no, earlier, 7790, yes. Came out with the 7790. Basically, yeah, 7790. It's used on the 295X2. It's made by On Semiconductor, as you can tell by the NCP part number. And it goes up to 4+2 phases, but here it's being run as just a 2+1, right? So you have 2-phase memory power, 1-phase VDDCI. The cool thing about this chip right here is it's super easy to modify. Compared to the 35217 you can also hard mod, but it's kind of worse, whereas this is a bit more old fashioned in terms of how it functions. So modifying the voltage control on this thing much easier and much less fiddly and annoying to do. Plus there's a full data sheet for this. Well, there, at least a while ago, it used to be like, I don't know if it's still available, but the full data sheet should be available for this chip. So this thing's super easy to mod. So yeah, if you want to try mod your VMEM or your VDDCI, you just need to punch that number into Google. It should come up with the correct PDF. Anyway, so running as 2+1. Oh, and you can do things like disable it has current limit, which you can disable. It has, obviously you can get voltage control, and I can't remember anything else. But you can definitely, like, disabling current limit on this thing is like you remove a resistor and no more current limit, which is kind of neat. But the thing is, at the same time, I don't think for VMEM or VDDCI, you're actually going to be restricted by current. Because normally the current limit is set for the self-preservation of the voltage regulator and not for the self-preservation of whatever it's powering. So if, like, it's, at least that's usually the configuration. So I'd be very surprised if you hit the VDDCI current limit, because that's a 55 amp power stage, and, because just more of the same NCP power stages everywhere. So that's a 55 amp power stage for VDDCI. There's no way the memory controller is going to suck up 55 watts all on its own. Actually, no, there is a way. If you degrade it in a couple seconds, it'll suck up 55 watts until it's dead. Like for a few seconds, you might be able to push that much power into it. So yeah, and that's assuming it could pull 55 amps at 1 volt. You'd probably need to push even more power into it than that, because the current draw is kind of proportional to the well, is the current draw increases with the voltage. So you need more voltage if you want more current draw. Anyway, so that's the VDDCI, and yeah, that's a 55 amp power stage, so not worth worrying about. Then for the VMM, 2 more 55 amp power stages. I'd assume this one probably runs hotter just because it's in front of the probably like, yeah, like it's jammed between the GDDR6 chips and the V-Core VRM. So this one's probably the one that's going to run hot compared to this one, because this one, like, there's a whole lot of empty PCB that Powercolor seems to have just done a massive ground fill on. So this all just acts like a heatsink for anything in the area. So yeah, this shouldn't have any problems. Like this would be the cooler running phase of the VMM. And again, like 255 amp power stages for powering the GDDR6, plenty of power delivery available. Though I do have to wonder about the polymers there. Because the thing is even with, like, I've not messed around with a lot of GDDR6 cards, but I did have a 2080 Ti for a bit. And one thing I did notice is that just adding capacitors, and admittedly pretty nice ones at that, helped with memory overclocking quite significantly. So, you know, it's just like maybe SMD aluminum polymers would, you know, be better for the memory overclocking, though at the same time I really do think that the main GDDR6 clocks, I think the main restriction right now is the memory controller, and it's not anything else on the cards. Like, yeah, because the other thing is like the cards, like there's well, if it was a PCB limit, I would assume all of the cards would just have the same exact wall. But it seems to be that some cards are a little bit better, so those would be like the cards with the little bit better memory controllers. And not so much, like, it doesn't matter what memory chips you have. It doesn't matter how you power them. It's just like which core has the best memory controller. That's probably the only thing that currently affects GDDR6 clocks on Navi. So yeah, that's the Red Devil, and somehow I managed to make this video really, really long unintentionally. So yeah, definitely, like, I can't really find anything to complain about, except maybe the choice of, you know, through-hole polymers on the memory VRM instead of SMDs. But the thing is, most of the cards do this anyway, and they all clock memory roughly the same. So yeah, that's not really, like, yeah, that's obvious. Like, the memory probably is just a memory controller thing, so that's not an issue. So yeah, this is a nice PCB overall from Powercolor. Like, you know, it obviously has some, like, well, Powercolor, if this is actually what you get on the retail card, then they might have actually been better off with just going with SMD polymers, but because they did just, like, this is fully loaded. Like, they're not, you know, leaving out any of the multi-layer ceramics. So yeah, I'm a fan of this thing. So yeah, you know, as I said, sometimes Powercolor makes some really nice cards. Sometimes Powercolor makes some cards where it's terrible, is the best way to describe them. But this one's definitely one of the nice ones. And yeah, you know, like, it, like, right now, I'd say this is probably the best 5700 XT. Because even, like, looking at the reviews so far, everybody's pretty happy with the cooling system Powercolor has on it. Yeah, the PCB is just like, well, the only better PCB right now is the Strix, and that one's way more expensive. And that card seems to have a less than ideal heatsink for a 5700 XT. So yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's also Teespring. So Teespring is for things like shirts, stickers, posters, all kinds of, you know, merch related to AHOC. You can check. And then Patreon is if you want to support me directly, you don't want to buy anything. So yeah, also Patreon supporters do get access to, like, a AHOC supporters Discord server. So if you know, like, I hang around there, and you get access to some, like, extra content, because I just post, like, random thoughts on there as well a lot of the time as well, if anybody cares. And also teasers of various things I'm working on. But anyway, so yeah, there's links to both Teespring and Patreon down in the description below. Also, one last thank you to Tech Power Up for the PCB pictures. Link to their review of the card will be down in the description as well. Thanks for watching, and goodbye.